this example. Let's say we have question given like limit x approaches e, limit x approaches e, ln of x minus 1 divided by x minus e. Evaluate this function. Now we can go ahead and see direct substitution and see what we get. To do the direct substitution, this is going to be ln of e minus 1 divided by e minus e. Now here ln of e is 1, so 1 minus 1 divided by 1 minus 1, that is 0 over 0, that is indeterminate. So we cannot use the direct substitution because we don't know what it is. Let's look at some other method. So here in this kind of problem, what we can do is we can actually apply L'Hopital rule. L'Hopital rule is basically taking the derivative of top and bottom, like the L'Hopital, according to L'Hopital rule, if you have a function, let's say x approaches a, f of x over g of x. If you have two functions like this, and if you take the derivative when limit x approaches a, it's going to be the exact same thing. Okay, it's exactly the same. That's the L'Hopital rule. Now here we can apply that one and see what we get. I'm going to go ahead and continue this one here. So if I apply L'Hopital rule, this limit function going to become limit x approaches e, and then if you take the derivative of ln of x, that's going to become 1 over x. And if you take the derivative of any constant, that becomes 0. And also in the denominator, we have x here. If you take the derivative of x, that's 1. And minus e is a constant number, so if you take the derivative, that's 0. So from this one, if we rewrite this one in a better way, we can write it as limit x approaches e 1 over x, and now we can go ahead and substitute. That's 1 over e. That's our final answer. Now we can also verify this one using some other method, like if you actually plug the 1 over e in the calculator, you're gonna get 0.3678 794412 794412. Now we can verify this one in another method. Okay, I'm gonna actually erase this thing. Let's keep the original equation because we need that one. I'm gonna erase this one. Okay, let's use a different color. Okay, so first, when x approaches e, now the number value of e is, if you plug it in the calculator, you're gonna get 2.718281828. Now when x approaches e, we have to take a value that's close to e, so we can take something like 2.7 and apply in this equation. So if we do that, limit, okay, sorry, ln, since we are applying the number directly, we don't have to worry about the limit. So ln of 2.7, I'm taking a number that's close to e, minus 1 divided by 2.7 minus e. And if you calculate this value using calculator, you're gonna get 0.369119121042. Compare this answer with this one. They're a little bit different, so we have to look at a number that is even closer than this to e. So if I take numbers such as x is equal to, here x is equal to 2.7, x is equal to 2.718, this is gonna become 2.718. This is going to become ln of 2.718 minus 1 divided by 2.718 minus e, and you can calculate this one. This is going to give you 0.3678985 okay. So this one is like a little bit closer, and as you get closer and closer to e, you're going to get accurate answer. If you want to try this one, x is equal to 2.71828, and if you plug it in the equation, you're going to get 0.367879565. So this is a little bit closer than this, right? So you can see as x approaches e, we are getting closer and closer to this number. And that's it for this video, guys. Thanks for watching. See you guys on my next video.